All right, let's get right into it. When we hear the word stroke, a lot of us think of it as some kind of disease, right? But that's not quite right. It's an event, a sudden, really critical attack happening right inside the most amazing, complex thing we have, our brain.
So, what is a brain attack? What's actually happening inside your head when one of these goes down? That's the big question we're going to tackle today. And to really get it, you've got to know that a stroke isn't just one single thing. Nope, there are actually two main ways this whole emergency can go down, like two completely different paths leading to the same disaster.
Okay, so at its core, a stroke is basically a plumbing problem. Simple as that. Your brain is being starved of blood. And why is blood so important? Well, it's the delivery truck for the one thing brain cells absolutely cannot live without: oxygen. Take that away, and they start to die.
And believe me, the clock is ticking. Fast. Just 5 minutes, that can be the window. You see, brain cells are unbelievably fragile. They need a constant flow of that oxygen-rich blood. Cut it off, and they can start dying in just a few minutes. We're talking about millions of brain cells being lost for every single minute that blood flow is cut off. And here's the kicker. Once they're gone, they are gone for good.
So how does the plumbing get messed up? Well, like we said, there are two main ways. First up, you've got the ischemic stroke. The easiest way to think about this is a blockage. It's like a total traffic jam on one of the brain's superhighways, all caused by a blood clot. Now, that clot could be a traveler, maybe it came from the heart, or it could have formed right there on the spot. Then, you have the other kind, the hemorrhagic stroke. This one's a bleed. A blood vessel actually bursts, like a pipe exploding, and blood floods into the brain tissue. The damage here comes from all that pressure building up. Totally different problems, but both are disastrous.
And then there's this thing called a TIA, which people often call a mini stroke. It's basically a temporary blockage. The symptoms might pop up, last for a few minutes, maybe a couple hours, and then, poof, they're gone. It is so tempting to just brush this off, but you absolutely cannot. A TI is like a massive warning siren that a huge, full-blown stroke could be just around the corner.
Okay, so this is where it gets really fascinating. Why are the effects of a stroke so different from person to person? It all comes down to location, location, location. See, your brain isn't just some gray mush. It's a highly organized command center, with different departments that each have their own very specific job.
So let's do a quick tour, shall we? Up here, in the front, you've got the frontal lobe. Think of it as the CEO of your brain. It's in charge of all the big stuff: planning, thinking, speaking, your memory, and telling your body to move.
Then, moving back a bit, you run into the parietal lobe. This is your sensor. It's the part that processes language and helps you make sense of the world through your sense of touch.
Okay, down here on the sides are the temporal lobes. These are the processors. They handle everything you hear, your ability to learn new things, and even how you process your feelings.
And way in the back, which is kind of weird when you think about it, is the occipital lobe. Yeah, the part of your brain that handles vision isn't anywhere near your eyes. It's the vision center that actually makes sense of all the signals your eyes are sending it.
And finally, tucked away underneath all that is the cerebellum. This is your master coordinator. It's what keeps you balanced and makes sure your movements are smooth and coordinated instead of, clumsy and all over the place.
But wait, it's not just about the different lobes. The brain is also split right down the middle into two halves, two hemispheres. And each one has its own kind of personality, its own special set of skills. And understanding this split is the key to understanding why stroke symptoms look the way they do.
So you can think of it like this. Your right brain is the artist. It's all about creativity, music, art, emotion. Your left brain, that's the logician. Logic, reading, writing, math skills, analysis, that's its domain. But here is the craziest, most important part. The wires are crossed. Your right brain controls the left side of your body, and your left brain controls the right side. Wild, right? So you can see where this is going, right? If a stroke hits the right artist's brain, you're going to see weakness on the left side of the body. That person might become impulsive, have a short attention span, and, this is huge, they might not even realize anything is wrong. But if the stroke hits the left logician brain, you get weakness on the right side, plus major problems with language, both speaking and understanding. That's a condition called aphasia, and what's so tragic is that these folks are often completely aware of what they've lost, which can lead to incredible frustration and sadness.
Okay, we've talked about the what and the where. Now for the most important part of this whole thing. What do you do? Because when a stroke is happening, I mean this literally, every single second counts.
And here's the thing you have to burn into your memory. Stroke symptoms don't slowly build up. They happen suddenly. Bam! And the best way to spot them is with a super simple acronym you have to remember. FAST.
Let's run through it. F is for face. Ask the person to give you a big smile. Does one side of their face droop? A is for arms. Ask them to raise both of their arms up. Does one arm start to drift back down? S is for speech. Ask them to repeat a simple phrase like, "The sky is blue." Is their speech all slurred or weird? And T is for time. If you see any one of these signs, it is time to call for help, immediately. And one more thing, try to remember what time the symptoms first started. That piece of info is absolutely crucial for the doctors.
So we know how to spot a stroke, but what about preventing one? And what does life look like after? What's the road to recovery like?
Well, there's another great little memory trick for the risk factors. Just remember the phrase, strokes happen. It covers the whole spectrum. Stuff you can change, like smoking or your weight, and stuff you can't, like your family history or just getting older. And look, there it is again, a previous TIA. It's a huge, flashing red light on this list.
For so many people who survive a stroke, especially one on the left side of the brain, the biggest battle in recovery is something called aphasia. It can be expressive, which is just heartbreaking. They know exactly what they want to say, but the words just won't come out. Or it can be receptive, where they hear you talking, but the words sound like gibberish. You can just imagine how incredibly frustrating and isolating that must be.
Another huge challenge is a strange visual problem called hemianopia. Imagine losing half of your vision, not in one eye, but half of the visual field in both eyes. It's literally like half of the world has just vanished. To cope, survivors have to relearn how to see, constantly scanning their head back and forth just to take in a whole scene and stay safe from bumping into things. So there you have it. We've taken a tour of the brain, we've seen the two ways disaster can strike, and we've learned the simple code to spot an attack while it's happening. The information isn't complicated, but knowing it can change a life. So it all boils down to one last question. For you, now that you know the science, could you be the one to act in time?